8.2 exponential functions. Now this is going to go into some graphing stuff. When it does get into graphing with exponential functions, and yes, the unit, I think it's called something like nonlinear situations, which we've seen before. But this is just graphing with tables, okay? So the nice thing about linear equations is that when we graph, you can use the slope and you can use the y-intercept to graph lines, right? But now that they're curvy, we can't, there's no consistency. Well, I mean, there is, but we're not concerned with that right now. So what we're going to be doing is using tables to graph these. Meaning, I like the vertical tables like this, and then we're going to be making these ourselves, right? So you're going to have to choose your own x and then solve for your corresponding y values in these. But in the end, what these do is they give us ordered pairs. Okay, then we can graph the ordered pairs. Once we see what's going on with those ordered pairs, we're in good shape. Now, when finding function values, replace x with the given value, right? So yeah, something like this one. If they gave us this function, f of x equals x plus 5, f of 4, and that's how this reads, f of x, now it's f of 4 means x equals 4. So to write this out completely, you'd say f of 4 equals, now it's not x, it's a 4, but 4 plus 5, and then you'd find f of 4 equals 9. And again, the nice thing about function notation, it does give you the ordered pair. In this case, it'd be 4, 9. X value is 4, the y value is 9. And then you could plot that point to represent this equation on a graph. And then I'll talk more about how to put these into Canvas. And in fact, I'll double check to make sure I got it down right too. So these types of problems, again, they've given us two x values that we got to put into that function. And so that's all we're going to do. Pretty much like we did at the end of 8.1, right? It's just now, you can see it's 2 to the power of x. Hey, no problem, right? So f of 3 would be the same thing as 2 to the power of x, but now we're saying the x value is 3. So replace your x with 3. Now this is good enough just to type into the calculator. But if you wanted to expand it, you could. 2 times 2 times 2, which is 8. Why are the 2's different sizes? I don't know. That was weird. But same thing with 4, right? So again, the base is still a 2, but now our exponent is going to be a 4 right there. So instead of there being 3 2's, now there are 4 2's all being multiplied, because that's what an exponent tells us. It's just a simplified form of repeated multiplication. And 2 times 2, you could even do this from left to right. You say 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, right? So there's 16. Now again, the thing we need to remember about both of these, is that this gives us then ordered pairs, such as 3, 8 and 4, 16, which then we would need to use to put this onto a graph. Now, 2 points is not good enough to put on a graph for curved lines. When you're doing it by hand, when you're putting it into Canvas, 2 points is good enough. Okay, but just so you can understand the pattern that we're going to be seeing, I would highly recommend that you have at least, I would say probably at least 5 points. All right, we'll see how that works with, especially when it comes to convenience, but we'll see what values make things convenient. But again, the whole idea with these types of exercises is that you get used to, one, being able to figure out your own values. But again, like I said in that first slide, when we get into equations where we have to make the table, we have to choose those x values. They're not even going to give us those. Now, to me, I think that's some pretty good freedom right there, but that doesn't mean you have to like it, because, well, it's still math, okay? All right, we're going to calculate these. I'm going to put these in fractions, and some of you may be wondering why I'm putting these as fractions, because I got this negative exponent. I'm not going to change the format of the function. I'm just going to use my calculator to solve these, okay? So f of 1, that would be 3 to the power of negative x, right? But now we're saying that the x value is 1. So replace x with 1. Don't worry about the negative. You can still plug this into the calculator. Now, whether you use the calculator or not, really up to you. You could say, well, the negative reciprocates this, then you'd have 1 over 3 to the power of 1. Well, just make it 1/3 and call it good. Okay, but if you put 3 to the power of negative 1 into the calculator, it will give you 1/3. And I like the fraction, and I think Canvas does too. What about f of 2? So again, this is x value that's 2, so that's 3 to the power of, so you got the negative, but now it's a negative 2, because we replaced the x. Again, however you look at this, you could say, take it step by step. The negative is going to reciprocate that, so now it's 1 over 3 to the power of 2. But the calculator would have given you this final answer directly. It's 1 over 9. Okay? And again, this is two ordered pairs that we got right here. This first one that we found was 1 1/3. And then the second one was 2 1/9. Now these gave us all y values that are fractions. Just kind of prepare us for future lessons here. Is if we wanted a whole y values, we would do that by making the x a negative value, which would be okay, all right? Or even to think about this, if you made x 0, what would that do? You'd have 3 to the power of negative 0, anything to the power of 0, because 0 is neither positive or negative. Anything to the power of 0 is 1, so you'd end up with a 0, 1 ordered pair, okay? That doesn't have to make a lot of sense. Maybe we'll see that in the future, we'll see. So this one sets up a little different. Why don't you guys try this one? Take a minute, try this one. We'll get it completed, and we'll take a 5-minute break, okay? All right, so the calculator would do this for you. And I'm pretty much going to have to use calculator, and I'll show you why. Okay, let's make f of 2 down here, so I have some space to work with. All right, so let's start with f of 3. And let's look at the function. We got 4 to the power of 2 times x, and then we're going to subtract 3. So remember your order of operations, you got to do your exponents. Now there's operations in the exponent as well, and then we can take that 4 to whatever that power is, but the x has to be replaced with the 2. The 3 rather. So that's 2 times 3. I'm going to bring this down to make this 4. 2 times 3 would be 6. And then we'll subtract 3 once we figured out what 4 to the power of 6 is. Now, if you're wondering what 4 to the power of 6 is, I'm wondering as well. It definitely is not 24, though. Do not do 4 times 6. This is really 4. I'm trying to use a red right here. 4 times 4 times 4 times some technology to take a shortcut. There we go. It's gigantic, right? And this is why I say I'm going to use a calculator for this one, because I don't want to do 4 times, which is 16, right? Then 16 times 4 is 64. That's as good as I am with 4s. Okay, after that, it's like, you could say, well, 64 times 64. I still don't know what that is, but the calculator does, so that's why we're going to use a calculator, right? So yeah, 4 to the power of 6, we got to put that in the calculator, right? That came out as 4,096. Now, you could just type 4 times 4 times 4 times 4 times 4 times 4 and get 4,096, but you can type this in the calculator. Remember, you're going to type the 4, that's your base, and then, again, this exponent button, it's one button to the left of 7 and one button up. And then you just put your 6 in there and then type in your equal sign, okay? And it'll give you the 4,096. So now 4 to the power of 6 we know is 4,096. But we still need to subtract the 3, okay? So what do we get when we subtract the 3? 4,093. So f of 3 ends up being 4,093, which again, if we were to put this on the graph, which we will be very soon, that would have been the ordered pair 3, 4,093. And how do you put 4,093 on a graph? You usually don't, because that number is pretty high. Remember, our graphs usually go up. I think now we're going to see some go all the way up to like 20, but we shouldn't see base 4s either, just for that convenient fact. Let's do 2, right? So again, let's look at the function here. So that's 4 to the power of 2 times, in this case, 2, because remember the x is 2. And then we'll still subtract the 3. Okay? So that'd be then 4 to the power of 2 times 2, which is 4. And I'm just going through the order of operations. And yeah, you know, just use the calculator is my recommendation. But 4 to the power of 4, 64, right? No, 256, I was way off. 256. Now minus 3. which is, which I have to give myself more space, 253, okay? So f of 2 equals 253, which again, this would be the ordered pair. It's a little bit bigger, but that'd be 253. And now, again, on Canvas, all you need is the 4093 and the 253, but in the future when we start graphing, we're going to need those ordered pairs. For the function f of x equals 5 to the power of 2x minus 1, we just want these two values, and again, this would be you making up your own x values, not them giving them to you. But for these ones, they do give them to us. That's nice. All right. So f of 3, again, this is the function of f of x, 5 to the power of 2x minus 1. Now, that minus 1 is in the exponent right there, okay? So, so don't get this mixed up. Make sure you understand that this minus 1 right here is a little bit smaller than that last problem where we saw that, what was it, minus 3? Okay, so this one is in the exponent. And, yeah, we're going to replace the x here with 3. And, again, you could, with that exponent button on the calculator, you could just type this all in. But I'll do a little bit of extra work here. So that's 5 to the power of 2 times 3 is 6. And then you'd subtract 1 from the 6. That would give you 5 to the power of 6 minus 1 is 5. And yeah, again, I don't know what 5 to the power of 5 is, but my calculator does. I got 3,125. Again, that's just from the calculator. But again, you could have typed that all into the calculator. But again, that would have been the ordered pair, 3,125, which would be hard to graph, but there it is, okay? Now we need f of 4. So that's 5 to the power of 2 times now 4 minus 1. But the x is 4. So a little bit more work, maybe even than you'd want to do because the calculator would do this. But 2 times 4 is 8. And then we'll subtract the 1. So that's 5 to the power of now 7, which the calculator knows. So I will use the calculator for that one. So I got 78,125. Which again, that would have been the ordered pair, 4, and then 78,125. Now again, we're not being asked to graph these, but you'll need to keep these in mind because when we do get to the graphing, that's our next couple of problems, you're going to need to keep those ordered pairs in mind. As we've seen, graphs of exponential functions, like I said before, you have to make your own table for these, okay? Which means that you're going to have to be choosing your own values of x. They're not even going to give you the table. All right, so you got to make your own table. Now, like I said, on Canvas, you're going to need 2 ordered pairs. That's it. That's all you're going to need, okay? But if I remember right, Canvas won't accept fractional values. So if you end up with fractional values, you have to keep going until you get non-fractional values. And we talked about how to do that, especially when the exponent itself is negative, okay? So we're going to graph the points, and then it's going to create, because I'm going to be doing more than 2 points on these graphs, but it's going to create a pattern, and then the pattern continues. The patterns, of course, they are patterns. It's just that they're not as convenient as y equals mx plus b linear equation type patterns, okay? This is just, I don't know, just some interesting facts, I guess, about this. But if your base is greater than 0, then it's called next. The base has to be greater. This is what that base has to be. Now the graph is going to look like this if the base is greater than 1. Okay, and as long as there's nothing else with the x or being added or subtracted to the base b, you should have the y-intercept always at 0, 1. Again, that's only if there's nothing being added or subtracted to the x's, whether it's in the numerator or the exponent or not. Okay. If the base is, because we can't have negative bases, if the base is between 0 and 1, then it's some kind of fractional decimal value, then it's going to look more like this. You don't have to memorize this stuff because it's all going to take care of itself when we start making our tables. But just keep in mind, this is kind of the foundation of what our graphs should look like in the end, which is why on the computer it knows that the graph should look like this. And so when you put 2 points on there, it just knows what to do. Okay, then yeah, we got the domain and range. There is no x-intercept. Oh yeah, why is there no x-intercept? Because no matter what the base is, again, we can't have negative bases, but no matter what the base is, you can't get a value that's ever equal to 0. You could get something really close to 0, and it could be infinitesimally small. I don't know, I feel nerdy saying that, but You can never actually reach 0. Even if the lines look like they touch, they're not, if you were to zoom in far enough. All right, so here's our first equation for us. Now notice, this line is blue, just, I don't know why it is, and it's even got these 2 dots. Ignore that crap, okay? But we notice that this one goes all the way up to 20. That's good. Okay, so once again, we got to pretty much create our own table of values here. We got x's and y values. I put 5 values in this, right? 1, 2, 3, 4, 1, 2, 3, 4, 5, 5 values. I can fit 5 values in my table. If I need more, then I would just expand the table. We'll see if we do, all right? It's just that our function is 3 to the power of x. Now, when you look at values of x to choose, you can choose negatives, you can choose positives. I always recommend choosing at least 1 negative. I'm going to go with 2 negatives on this one, though, okay? And it should kind of confirm the pattern for us. These are going to give us fractional values. I don't care about these fractional values because I just want you to see what is happening in the graph. A very convenient value to use is 0. Okay, especially when there's nothing being added or subtracted to my x exponent, okay? And then, of course, I'm just going to go the other direction with 1 and 2. See if this fits. In fact, yeah, this is going to fit. I couldn't go up to an x value that's 3 because 3 to the power of 3 is 27, and that's not going to fit on this graph anyway, so I'm going to ignore that, okay? Let's go ahead and find our first y value where x is -2, okay? So I'll give myself a little space here. We'll say f of, now it's -2, right? So that'd be 3 to the power of -2. You're welcome to put that into the calculator. We've already solved that one, but it's still 1/9, which is, I do need the decimal on this one just because I'm going to put it on the graph. It's 0.1 repeating. I put 2 ones, but whatever. So let's see if I can fit this on there. Okay, -2 and 0.1. Again, even the hundredths right there would be very difficult to graph. That red dot, not this one or the other square one, this one right here, okay? So that's -2 and approximately 0.1. Now again, you wouldn't do this on Canvas because, like I said, I don't think it's going to accept the partial values, the decimals or fractions, okay? But again, I want us to be able to see this. So in my table, by the way, I probably should put that in there. That gave us 0.11 there as well. Well, 0.1. Because again, I couldn't really fit that hundredths in there. Well, what about -1? Well, let's do this one in purple. Okay, so that's f of -1, right? So that'd be 3 to the power of -1. We've seen that already as 1/3, which is approximately 0.3. Okay. Now, I know the 3 repeats, but I don't really care about that because I can't fit hundredths on my graph anyways. So I'm just going to use 0.3. Where is that on my graph? -1 and 0.3. It's still less than half, somewhere in this range. Right there for my purple point. Now you can see that it's starting to increase, which is good. We should see some increasing going on because our base is more than 1, okay? Next up, now the x is going to be 1 on this one. 0 rather, sorry. And I'll do this one in green. So we're looking for f of 0. I've chosen the x to be 0, so that's 3 to the power of 0. Anything to the power of 0 is 1. That's easy enough to graph. 0, 1, that's our ordered pair. 0, 1, that's our y-intercept. Okay, that's the green ordered pair. Let's go to the next one. These are getting easier, you see, and there's a reason for that. It'll take some experience to really get used to it, though, but now I'm looking for f of 1. That's 3 to the power of 1, which is just 3. So I get the ordered pair 1, 3, which would be right here. Now, just from this pattern, you can see that it's curving upwards, right? It's going up pretty fast. And towards the left, it's getting very, very, very close to 0. But again, you can never actually reach 0 on the x-axis right here, okay? Now, let's try that last one. We got f of 2, right? Do this one in blue. It's f of 2, which makes it 3 to the power of 2, which is 3 times 3 is 9. So that's 2, 9, and we can fit this one on the graph. 2, 9 would be right here. Now, the next one would have been 3, 27, way up here, way up there, okay? Sorry, way up there. But this is good enough. And like I said, on Canvas, really you should only need these 2 points. If you wanted to do these two, it would still understand, okay? So they don't have to be right next to each other, just any 2 points. Again, you wouldn't be able to use on Canvas these fractional values, but you can see it's easier just when you used positive values for your x's. So why did these come out as decimals? We talked about this already, but it's because the negative exponent reciprocates that, which would have made this 1 over 3 to the power of 2, which is 1 over 9, okay? So if you force the exponent to be a negative, then you get those fractional values. Now again, I did this because, well, it's nice, you know, to be able to see these and how they work. Let's see what the graph would look like approximately. I'll try not to mess this up too bad. Now, I'm going to make that line. I'm just going to show that it goes forever to the left here, getting ever closer to 0. But I just put an arrow there at the end. When I do this, I also start with just the y-intercept. I don't know why I do that, but I kind of split it in half, so I got a couple different tasks to do. But see if I can do this next one. I can do better than that. I think I could do better than that, but I don't know that I'm going to get much better. Sorry. But Canvas knows how to do that much better than I just did. Okay. But that's what our line looks like. And again, this would keep going upwards like this, in this direction that way. Okay. So, well, that made it more sloppy, but hopefully that kind of makes sense. So for this one, the base now is a fraction, and again, that's not so bad. It's just, from what we saw a couple slides ago, it just means that it's going to go up towards the left. Now, we're going to show when we go through the values why that happens. But again, let's go and start our table right here. Okay, so we got x's and y's. Again, I'm going to look to put in 5 values. And I'm going to choose the same values for x's. Okay, so I'm going to start with -2, then -1, 0, 1, 2. And I know our base is a fraction right now, but I'm going to choose to make my y values decimals when I need them to be, okay? Because again, it's easier to graph with decimals than it is with those fractions. Although the calculator will be doing most of that work for us. So, all right, so we're going to start with x being -2, and I'll do this one, I'll do it in the same order here. Start with red. So that's f of, we're going to start with red, f of -2. But now this is 1/2. Make sure you use parentheses when you put this in the calculator. And but it's a -2 exponent. Okay, now that -2 exponent, I'm going to show more work than you need to because the calculator would do this for you. But -1/2 to the power of -2, that negative reciprocates that fraction, so it's really 2 to the power of 2 over 1 to the power of 2, which is just 2 to the power of 2, that's 4. Okay, so I get that ordered pair, -2, 4. And I'm going to complete the table before I put the points on the graph this time, all right? Although it doesn't matter what order you do it in. But you're just going to need the ordered pairs, of course. So next up, I'm going to say, what if f is f of -1? X is -1, right? Well, then you have 1/2 to the power of, now it's -1. And the negative for that exponent just reciprocates the fraction. So it's 2 over 1 to the power of 1. That's just 2. Okay, so I'm going to put a 2 right there. You got -1, 2 is that ordered pair. Next up, we'll say, well, what if the x is 0? So that's f of 0 equals 1/2 to the power of 0. Anything to the power of 0 is 1, so we get the ordered pair, 0, 1. So you can see just from the values that we have, right, as the x increases, -2, -1, 0, the y values decrease, right? We went from 4 to 2 to 1. So we're looking at an inverse relationship, which we've talked about a little bit before. I'm just bringing that up because we may see something like that on the final, right? Let's look at f of 1, though. So that's 1/2 to the power of 1. Anything to the power of 1 is itself. So we just get 1/2 out of that, which is, as a decimal, 0.5. And again, I'm only using the decimal because it's going to be easier for us to graph that way. And then finally, we got f of 2. X is 2, so that's 1/2 to the power of 2. 1/2 times 1/2 is 1/4. But again, the decimal there would be 0.25. Now, you could say 0.3, just round that. It's a very common decimal, though, so I'm going to keep it as 0.25, even though I can't put hundredths, probably, on this graph. All right, so let's get these points on the graph. So I got negative 2, 4, which would be about right there. I got negative 1, 2, which is here. And then 0, 1, that's on my y-intercept. And then 0.5, again, that's just halfway up there. That's not too bad. But the 0.25, that's the one that's pretty rough, you know, in this area. So again, we see the curvature of this line, and it's going upwards. Now, I know I didn't put these points, or actually figure out these values. But if you did negative 3, you'd get 8, and then negative 4 would be 16 right there. Okay, it just gives me something to work off of when putting my line down. So let's see, what do we get? Again, I start from the y-intercept. When I'm doing this by hand, it just kind of, I don't know, gets pretty close to that x-axis. I know it's touching, but it's not supposed to. But I'm doing it by hand, so here we go. What about this next one? I put those extra points on there. Let's see if it helps. Yeesh. Well, I feel like I do it better on paper, but I don't know that it's much better. There's our graph. We did do, you know, we did several graphs, linear graphs with tables as well. So hopefully the technique itself is not foreign to us. And again, if you're letting the calculator do a lot of this heavy lifting for you, then hopefully it goes pretty well, right? So on this one, let's go ahead and make ourselves a table. Put it right here. So we got x and y values. Again, I would like to have at least 5 values there. Oh, but that's 4. That is a 5th one. Okay. Now on this one, I don't really care about the base being 1/5. Okay, but what I do care about is that I got x minus 3 up there. Now, if you think about this, to get the exponent, the full exponent to equal 0, the value of x that would make that exponent 0 would be 3. So I'm going to put 3 right in the middle. And then I'm just going to go in both directions, right? So I'd go downwards, that'd be 2, 1, and then upwards, 4 and 5. And again, if I have 5 values, that should be enough to see what the pattern is. But I'm specifically using 3 in the middle because it should give me an exponent that is 0, which correspondingly should mean that I should get a 1 y value. But we'll check. Okay. Let's start with x is 1. Okay. So that's f of 1 equals 1/5, still in parentheses, but that's a 1 minus 3. That'd be 1/5 to the power of negative 2. Now you could reciprocate that and make it 5 to the power of 2, but it's just 25. I recommend using your calculator for that, okay? So I got the ordered pair 125. That's not actually going to fit on this graph, right? Because it looks like it definitely doesn't go up to 25. So 125 is not going to be there, but it's still good to see. All right, what if we made the x value 2? Well, then it'd get 1/5. Oh, there's a 5. That's a 5. To the power of 2 minus 3. So that'd be 1/5 to the power of now negative 1. But that just reciprocates the fraction into 5. So we get the ordered pair 2, 5. And this, again, since I've kind of forced this x value to be 3 next. I'm expecting the y value to be 1, right? Because the exponent should be 0. So we got 1/5 to the power of 3 minus 3. That's 1/5 to the power of 0, which is 1. So yeah, that we did that one correct. How about the next one where the x value is 4? F of 4, there we go. Well, that'd be 1/5 then to the power of 4 minus 3, which is 1/5 to the power of 1, which is just 1/5. But like I said before, I'm not going to show the fraction because the decimal is a little bit easier to graph. 0.2. That's a nice decimal to graph. How about this next one? So that's x is 5, right? F of 5. So 1/5 to the power of 5 minus 3. That would be 1/5 to the power of 2, which is 1 over 25. I don't know what that decimal is, so I'm going to go to my calculator for that one. 1 over 25. Use the double arrow button if you got to, but I got 0.04, which is pretty close to 0. I can't even round that up to 0.1. So I'll just try to make this as close to 0 as I can, all right? In any case, this is what it looks like, right? So we got, I'll start with, I can't do 125, but I can do 2, 5. So 2, 1, 2, 3, 4, 5 is right here. Yeah, because our scale is 1, right? So we got 3, 1, 2, 5, then 3, 1 is here. Then I got 4 and 0.2. That's going to be pretty rough. 4 and 0.2. Yeah, it's again, 0.04. Where the crap is that? It's pretty close to that x-axis though, okay? All right, so what would happen here if we went even lower? So we know that 125, it's way up here, right? So even as I make this line, I'm going to try to make it not cross this x value that's 1. Let's go and see what that looks like. So I know, and by the way, this would be considered the y-intercept, even though I know it's not going through the y-axis because I made the exponent 0. However you want to look at it, okay? But it's not that it is the y-intercept, it's that it's related to it. Okay, so I get this kind of black line right here, and then to the right, you know, even right now, I would just kind of like stop right there. You're welcome to continue that line though, upwards if you want. But yeah, again, we see this line. This is kind of like 1/5 to the power of x. It's just the -3 has moved it to the right 3 units. Okay, so it's kind of like if you had the y-axis right here. Again, where the y value is 1, that's kind of like what would have been our y-intercept, but it's just been shifted over to the right 3. Now, you don't have to know why it shifts to the right 3 yet, but you may notice if you do this enough what the pattern is there. The truth is, if you can, right, we see this, the fractional base, we saw the regular base, and then we see stuff that's happening in the exponent. If you can do that, then there shouldn't be anything that's super surprising on the homework. Of course, they're going to use different values, but the process is the same. Use the table, graph the points, connect the points, boom.